Hello everyone, this is Training and AutoML Working Group Community Call on 4th of September. This meeting is governed by the Kubeflow Code of Conduct, and this meeting will be recorded and published on YouTube. Welcome everyone. So I think maybe we can get started this call with a maybe quick introduction. Do we have any new people here on the call who just want to introduce themselves to the community? Maybe just want to say hello.
Yeah, I am new. Hi.
Yeah, yes, I think if you're speaking, we almost can't hear you.
Can you hear me now?
Yep, we can.
Yeah, so I'm here, new here. So hi everyone.
Nice to see you. Nice to see you. See.
Hi, so I am Jyotin. So I am an undergraduate student in the Indian Institute of Technology, Jodhpur, and I would love to contribute here. I'm in my junior year, and I'm just getting started with Go and machine learning. So I would love to contribute here.
Nice to see you, Justin. Thank you for joining. Thank you.
Uh, Hello, community. My name is Sailesh. I'm a new graduate who's currently working in Nutanix. I have done a bit of open source in case of before, but this is my first time in the other repos of Kubeflow. So I'm excited to help in contribution.
Thank you, Sarish. Nice to see you. It's cool. Anyone else want to say hello?
Hi, I'm Shashank. I'm currently the GSOC mentee for Project H. Uh, I have I've been working on supporting parameter distributions in Papers.
Thank you, Shashank. Thank you for joining. All right. Anyone else want to say hello before we get started? All right. So I think we have a few topics today to discuss. I think the first one will be the Slurm demo that we kind of like want to have last week, but just don't have enough time to discuss it. So maybe we can just straight away jump to the demo. Marla, what do you think? Do you need to share your screen?
I do.
Yeah, let me just give you permission. Yeah, I think you should be able to share a screen, so you can just move forward.
There we go. Can everyone see the screen?
Yep, it's visible.
I don't know why Zoom does that. Okay. Hi, I am Marla Wernicke. I am a developer over at SkedMD. I'm here accompanied by Alan. He's going to help me co-present, and Skylar is here for backup because he has more expertise in Slurm proper than I, either myself or Alan. And we're here to talk about Slinky. Let me tell you what SkedMD is first. We're maintainers and supporters of Slurm. We're the only, I'm just realizing I don't have video on. We're the only organization providing level 3 support for Slurm. We also do training, consultation, and custom development. What is Slurm? For those of you not familiar, it allocates access to resources for users for some duration of time per workload. It provides a framework to start, execute, and monitor that work. And it arbitrates contention for resources. And it's policy driven, it's open source, very specifically, it's fault tolerant, and it's basically a workload manager, a job scheduler. It's highly scalable. That is the thing that people really want. But it also has a lot of features inside of it. What is Slinky? We're a collection of projects and initiatives to enable Slurm on Kubernetes. The one we're presenting on today is the Slurm operator, which manages Slurm nodes in Kubernetes. The next thing we're working on will be the Slurm bridge, which is to enable Slurm scheduling of Kubernetes pods following this Slurm scheduler. Ultimately, we want to get these to work natively together and well. That will take some community work. Here's our general domain pools. So when you do run this, this is what your domain pools look like. So you have Kubernetes, you have one or more Slurm partitions, where Slurm manages its nodes running a Slurmd. And then our tooling will manage the scaling on the Slurm nodes through a Slurm operator. I put this slide in because people in HPC and people in cloud native come from different universes, and it's really helpful to go through this content every time, partially because it helps you understand why the initial systems are the way they are and what sort of think you have to break through in order to get your solutions into the other spaces. HPC, your underlying software is mutable. They assume fine-grained control of that node. Users are often systems experts that understand infrastructure, and they have a high tolerance for complexity. That's how they're trained. Their access to compute is handled by a resource manager or scheduling system. The users own the node entirely during computation. And there's an assumption of node homogeneity. I know that's none of these are 100% for every HPC system, but it is overwhelmingly what most of them look like. Cloud native, your underlying software is immutable. You can't change what is running beyond your container. Users are not systems experts. They do not think in terms of parallel compute. They have a very limited tolerance for complexity. The users share the nodes, which introduces jitter, can blow through your bandwidth. We see all sorts of solutions trying to address this. There's an assumption of heterogeneous nodes. You do not know what you're running on, and there's not a ton of attention given to network topology in general. I know that, again, this isn't 100%. I know there are individual projects to address each of these, but this is not a perfect system. So we want to talk a little bit about why Slurm. So we want to talk about the easily transferable Slurm scheduling features. These ones are all transferable with the operator. GPU reservations and scheduling allocation of jobs. If we're already scheduled within the system, we will handle that as far as if we own those GPUs. Priority scheduling, fair share, and quality of service. Quality of service is a little different than the Kubernetes definition in that it's a set of policies such as limits of resources, priorities, and preemption and backfilling. These are the other sets of features, and I really like this set because you don't really have concepts like this within Kubernetes proper, which is job accounting, which is information for every job and job step executed. Those jobs, you don't get that within Kubernetes. You're either running or you're not running. There's also job dependencies, which allows users to specify relationships between them. So from start, succeed, failure, or to a particular state in the middle. These two in the middle are grayed out because until we have some components, we're not going to be able to guarantee that unless we're doing the Slurm scheduling entirely. So until kubelet allows for the gap to be closed so we can do fine-grained CPU or memory control, we're not going to be able to do that. Similarly, we might be able to do node proximity, but bandwidth and latency, again, we're not going to be able to guarantee. And then we'll allow workflows with partitioning, which divides cluster resources into sections for job management. Do we have any questions so far?
I think looks good to me. Any questions from folks on the call?
Okay,
Great.
not yet. I'm going to hand this over to Alan, who's going to go over the architecture for the Slurm operator. Alan?
Hey, everybody. I'm Alan, also from SkidMD. You can go ahead to the next slide, Marlo. So just before we talk Slurm operator, the kind of the internals, it helps to go over what a Slurm cluster is and what daemons are necessary for a Slurm cluster. And that kind of starts with Slurm CTLD. That's the control plane. So the Slurm control plane kind of sits in the middle. Slurm CTLD, it talks to things like Slurm accounting. So there's Slurm DVD, which is backed by either Maria or MySQL database. There are Slurmd daemons, and those are running on the nodes. So kind of map that to kubelet in the Kubernetes world. So Slurmd is running out on all the nodes that you would want your Slurm jobs to run on. It will launch things like Slurm stepd. So that's a job agent that would be responsible for sort of shepherding the job along, managing the life cycle, and fanning out communication back to Slurm CTLD. There is the Slurm REST API that obviously lets us communicate to the Slurm cluster over the network, and that's used heavily by the operator. So the operator kind of sits between Kubernetes and Slurm. So Kubernetes, it's talking to the Kubernetes API. When it needs to do things in Slurm, it's doing that over the Slurm REST D, the REST API. Not in the diagram, but in the list of bullets is SACD. So that's authentication credential agent. If you're familiar with Slurm, you may have seen Munge. SACD is now this replacement for Munge that sort of opens up the door for us to extend the features of how we use the tokens and how we authenticate and do credential management. So you can go ahead, Marlo, to the next slide. Now, how you would submit a job to Slurm, two primary ways. Obviously, you could come in through the REST API with a token, and that token would need to be generated by Slurm CTLD. So you hand that token with, and you would submit your job to the job endpoint. Slurm CTLD would take that and get it scheduled and then launch it out on Slurmd. Those are all the nodes in the Slurm cluster. Similarly, you could, what people often do is have a login node that is authenticated to the Slurm cluster. And from there, you can use Slurm CLI commands to do the same things. You can schedule your job or interact with it or interact with the Slurm cluster with CLI commands. Okay, so now that we've talked about sort of the Slurm basics, how we fit this into the Kubernetes world, and the big picture of the operator is that we're introducing two CRDs, two custom resource definitions, and that is that's at the top left of this diagram. The cluster CRD, first and foremost, is, I like to think of it as kind of a pointer to your Slurm cluster. So that custom resource would have a reference to the URL where you could communicate to the Slurm REST API and a reference to the credential or the Kubernetes secret. So that's how the operator knows about a Slurm cluster and communicates to it. The second CRD is the node set CRD, and that is your pool of compute resources in Slurm. So a node set custom resource would represent a type of node, maybe, or a Slurm partition where you're running your Slurm workloads. So when you apply these custom resources, like a cluster CR and a node set CR, obviously the Slurm operator's job is to sit and reconcile the desired state with the current state. So an example of a cluster CR would say, there's a Slurm cluster added to this Kubernetes environment. I'm going to make sure that I could communicate to it with the Slurm REST API, that it's healthy, and then it would update the status of that custom resource. So it would say, like, the Slurm cluster is ready. And then with the node set CR, the operator would be communicating to both Kubernetes and Slurm to spin up Kubernetes pods that represent those Slurm nodes. So that would be Slurmd. Slurmd is what's running in the pod out on the compute nodes to communicate back to Slurm CTLD. And now with Slurmd out on those compute pods or the Kubernetes nodes, Slurmd itself is registering itself back to Slurm CTLD. So it's kind of communicating directly to Slurm CTLD. And provided that it has the communication channel and the credential, it's able to dynamically register itself with Slurm CTLD. I think that's a Slurm dynamic node feature. So that would be the node sets CR's job, is to represent those nodes. Okay, I think we can advance one. Internally, the Slurm operator, the architecture is that you have a Slurm operator and that there are two controllers, a controller for the cluster CR and the node set CR. So kind of like what we've talked about is you apply a custom resource, the operator cluster controller will spin up Slurm client, which is similar to Kubernetes, how it has a Go library to communicate to Kubernetes API. Likewise, we have one for the Slurm client. So there's a Go client that we can communicate directly to the Slurm API. We do some caching and some informer loops so that we're pulling Slurm API, arbitrating those communication channels. So that cluster controller would be in charge of talking to the API, Slurm API, making sure that cluster is ready. A node set CR would be doing things like we've talked about, spinning up a pod that contains Slurmd. And the Slurmds would then register themselves with Slurm CTLD. And once everything's up and running, obviously they still need to monitor state and reconcile updates or deletions. And it's important to have this node set controller have the intelligence to manage both the Slurm world and the Kubernetes world. Because you can imagine you delete a pod in Kubernetes that represents Slurmd, you'll want the node set controller to be kind of mediating that transaction so that you would drain the node in Slurm. There might be workloads running on that node. You want to give them give the Slurm jobs a chance to complete before you fully take that node out of Kubernetes. And you can do things like auto scaling through the node set controller, which I think takes us to the next slide. We do have, through this design, putting everything in custom resources and Kubernetes objects, it fits naturally with this auto scaling concept where we have now Slurm metrics collecting data from the Slurm REST API and bubbling that up through Prometheus exporter and Grafana. We've also used Keta and horizontal pod autoscaler. So one example might be you would have a node set CR that dynamically scales itself up and down based on the length of the job queue. So as you apply workload to a particular Slurm partition, the Slurm metrics picks up on that, bubbles it up to the metrics API, and your autoscaler would scale up the node set. The Slurm operator would find a node to run that Slurmd, and it would scale up based on demand that way. You can also have the node set CR just simply fan out to all the nodes that it matches with its selector. But you could also operate in this auto scaling mode. Okay. Marlo, you can go ahead. I think we're
Can I ask you a quick question, Alan, like before we jump to the demo? So all of the communication between user and Slurm cluster works via the clients, right? Because like you need to pass the notification, right, to connect to the Slurm cluster, right, via like the Slurm login host. Is that correct?
Yeah, could you repeat that? I'm not
Basically,
quite sure.
how like I guess like my question is like all the communication between the user and the cluster is happening via like the Go client, right? That you offer to the user, right? So they don't really directly. So my question is, how do they submit jobs on the cluster?
Yeah, I think through the REST API, you could submit your job that way, whether or not you actually have the Go client library, or you submit through like a curl request, or
So I guess this REST API, yeah. Go ahead.
or you're using the CLI commands from an authenticated environment that can communicate to Slurm CTLD.
So all this REST API basically exposed by API server, which is like running on the Slurm cluster, right? Similar to how we interact with the Kubernetes API server, right?
Yeah, you would have some load balancer service where you can hit that REST API, correct?
And how do you track those jobs? I guess like you have this MariaDB, right, for metadata tracking, right?
Yes. Slurm accounting has all sorts of ways of tracking and correlating it to which user or different quotas, things like that.
And the concept of the job basically, it only like does it have it's like what does like the concept of the job in the Slurm world means? Like, is it a container or it's something else?
Yeah, see if Skylar can hop in, but I'll give it my best shot. A Slurm job would be some trackable resource in Slurm CTLD where it's you get a job ID, and then there might be various steps along the way that you run inside that job. So it doesn't map necessarily to a container or some Kubernetes resource per se. It's like an internal Slurm representation of a job.
You can run OCI to containers, though. There is an extension for that. Skylar, do you have anything you want to add to that definition?
I suppose what I would add is that a Slurm job, right, similar to Kubernetes, is you have a set of CPU, memory, and potentially additional requirements that Slurm calls GRES and TRES. Basically, other things like GPUs, You could even track bandwidth and other types of constraints for your job. Typically in the Slurm world, we're talking about batch jobs. So there is a finite life cycle to jobs, unlike in Kubernetes, which typically are more service driven, right? Indefinite life cycles. So I guess closer to the Kubernetes concept of like the batch V1 job. As Marlo said, yes, Slurm can do OCI containers. So you can actually launch your job through an OCI compliant container backend, or you can run your job, which usually runs on localhost using the installed binaries on that node, which is very different from the Kubernetes world. In terms of accounting, accounting is dealt with through multiple subsystems in Slurm, through the control plane, through the Slurm Ds, as well as through stepd. And all of that information is back propagated to the controller that then tells Slurm accounting to insert it into the database with the proper user account, job, and resource allocations and all the timing information therein. Okay, hopefully that's answered your question.
Yeah, that makes sense. Makes sense.
Any other questions before we head to a demo?
I have a few of them, but maybe I can ask them after the demo. So maybe we can discuss it after the demo.
Okay. I'm going to move that over. Can you see this?
Yep.
All right. I'm going to start here. You see I ran a bunch of jobs earlier just so you can see, can handle stuff. This does not include Slurm. So we have Slurm compute. These are 2 nodes. This is a simple kind cluster just for demo purposes. We have our Slurm controller, Slurm metrics, and the Slurm REST API. You'll have to trust me that there's a Slurm operator in the background. We have a single partition. It is the default partition. It is named purple. So because nothing is running now, go anytime. 0%, nobody's running, right? No jobs are queued. Just to prove we can run things, I have a benchmark here. There aren't many benchmarks that you can run on your laptop. This one is AI benchmark. It is pulled from AI benchmarks that are meant to be run on cell phones. Everything else, you need obscene amount of memory. I can only run one at a time. So the way you submit a job, to your question, Andre, is to run sbatch. You'll notice in this sbatch command, and maybe we should come back and do a Slurm, how does Slurm work presentation. That would be people, not me. We're doing exclusive, meaning it's the only thing to run on that node. If I don't do that, my computer out of memories and crashes. And sbatch and number of nodes. We're only going to do one. And then you see this get allocated. And now it's on the kind worker 2. And the other one remains idle. We should see this come up if we give it a few seconds, because metrics always takes a moment to be pulled in. Here we go, 50%. Half of my partitions or nodes in my partition are running. And just because I like to live dangerously, we're going to go over, although this hasn't gone badly yet, famous last words. These are those previous jobs. This is basically running a pile of sleeps. Some of these are exclusive. That means the only thing on the node, some are not. So you can have multiple ones per node. Oh.
Yeah, it looks like you just have to run that one directly.
Yeah, because I'm running a fetch. There we go. We see all of these go in. One of them is already running on the other available worker, and the rest are waiting for resources. And so now we should see this, because I just added about 35 jobs going up, and then they'll start to get allocated. And then up here, you see the allocation. So there's only 2 nodes, so it's very Argyle pattern for this. But here's your total jobs, and then your running, and then pending. So pending is 37, 2 are running because we only have the 2 nodes, with the total being 39. And I do want to wait until, okay. Okay, good. I like to prove that we actually ran something. So, you know, this is all inference time and then training time per job. Any questions on this?
Yeah, makes sense to me. Any questions from folks?
Ask question.
Yeah, go ahead, Kiki.
Yeah, thank you for great presentation. So, as my understanding, so actual job process is executed by OCI container, right? So, in that case, my question is, which components does actual job are managed by? So I mean, so the actual job are managed by kubelet or Slurm demo?
The Slurm control plane.
The
I see.
Slurm D is the component that actually is kicking off the job.
I see. So in that case, so the actual job is scheduled to Slurm scheduler or Cube scheduler?
In this case,
No,
it's
go
NC
ahead. Go ahead.
I'm sorry, Marlo. That's
No,
Slurm
go for it.
is scheduling the job.
I see. All right.
I
So
think there
thank you.
might be a little bit of a confusion. The jobs that Marlo has submitted is directly into Slurm, not into Kubernetes. So in Kubernetes is we have a virtual Slurm cluster, and then Marlo submitted batch work into Slurm, and then the Slurm control plane is dispatching that work to the Slurm Ds that are running as pods under Kubernetes.
So it's like similar to Spark concept, right? If you start a stateful Spark cluster, you can submit a job directly on the Spark cluster, right? And all the processing is handling by the Spark control plane. So I think the idea is quite the same. Like you go through like an authentication model to authenticate yourself to this cluster, and then the job has been processed in the Slurm entity. I guess like the question is like how autoscaling in that case works. So can you do, what if job requires more resources that your cluster has in the X period of time?
You can do metrics based on like pending jobs. So if you find that there's jobs that just aren't getting scheduled, you could have an attempt to scale up the number of nodes. I guess if it's more CPU or memory than you have, there's not much you can do, I guess, if you scale up and you can't reach that threshold.
I see. So basically it doesn't, for example, like it doesn't trigger the Kubernetes autoscaler, right? If the Storm cluster doesn't have sufficient resources to schedule my job.
You could have metrics just based on however you want to define them, everything that's exported with Slurm. So
Okay.
you could drill down to like job granularity, or you could do things based on a Slurm partition is kind of another way to represent a queue of jobs, or rather nodes, I guess. So if you can see that a particular partition has a lot of pressure from incoming jobs, you could decide to scale up that way.
The other answer, I think, to the question is that if you don't have the available resources and you can't scale up, it just sits there. So if you ask for 3 nodes and you only have 2, it's not going to get scheduled. Skylar, is there a timeout for that?
So no. But what you can do in Slurm, depending upon your configuration and your computing workload model, say if you're saying that you want your Slurm cluster to be a finite size, so you don't have any auto scaling configured, you can actually in Slurm reject jobs that go beyond your Slurm cluster's limits. So if you have hypothetically 128 cores, but a job asks for more than that, then with this enabled, you'll have it automatically reject that job. So it never gets pending because it knows that it will never be scheduled. Within the auto scaling case, though, you don't want jobs to be rejected because you know in the future you can scale up resources to deal with those pending jobs.
Yeah, that makes sense. So I think like I'm more interested in terms of the benchmarking, and maybe you've done some testing. So do you? I see the value of running Slurm on top of Kubernetes, right? And this makes sense. I think my question, like, for example, when people do like PyTorch, right, natively on Kubernetes, right, just using the jobs, right, and then they may be using Slurm, like, what kind of benefits they're getting on the scalability perspective, right? Do you make any benchmarks for specific for training side of things, and when it's become very useful from the user perspective?
So there's really 2 parts to that question. One of them has to do with the fact that Kubernetes doesn't have any schedulers that handle all of this, and we're working on the scheduler component that will be cleaner. But if you already have this running on your nodes, you get all of this particular type. We haven't gone and tried to run PyTorch, but it should just work because it's a set of libraries. Actually, I think that other one is PyTorch, the AI benchmark. But as far as resources and getting those to be optimized, that's going to be part of the scheduling piece that we need to write, which will be have a lot more information being pulled in. Because right now, if you look at Kubernetes proper, we cannot do the CPU and memory assignment that Kubernetes, because Kubernetes does not have very good granularity. So there will have to be some component, either through DRA or some other piece. I had a DRA working in my last job that will have to go through and do that granular assignment. And the network topology piece as well will have to figure out how to get better control on the node so that you don't have some side job coming in and just wiping out your bandwidth. Does that make sense?
Yeah. How does it handle granular control for GPUs? So can you partition GPUs on Slurm clusters, or how does it work?
It is whatever is supported currently by the GPU company. So I believe we have a plugin ability, and Skylar, correct me if I'm wrong, for that we are supporting. I don't know if it's in flight or done. Do you know, Skylar?
So in terms of Slurm supporting for GPUs, yeah, so Slurm supports a number of well-known GPU vendors, right? The big 3 being NVIDIA, AMD, and Intel. And those plugins in Slurm mainly handle auto detection of GPUs on board the node, as well as accounting data for those for the GPUs in the jobs.
Do you know if we handle dynamic partitioning yet?
Dynamic partitioning? What do you mean?
Yeah,
So
like me.
if I want, go ahead.
Yeah, like multi-instance GPU, for example, right? If I, for example, want to split my, my GPU between multiple jobs that are submitting to Slurm, can I do so?
If your GPU is a MIG, Slurm does have MIG support. Slurm also has the concept of GPU sharding, which is unenforced job utilization of the same node, and that's because no GPU vendor really enforces this with their libraries, but we allow sites that want to use this to so sites will have to monitor their users and do enforcement policy therein to make sure jobs cooperate in the sharding model. So yes, the short answer is we do support MIGs and splitting of GPUs that way.
Yeah, I think what would be really helpful for us to like understand. So I guess like the main 2 points, as you mentioned, Marlo, is granular job allocation and then network topology, right? So because I think the question for the network topology, like I was speaking about only like on-prem clusters, and also like public cloud accounts value, because like I remember previously we've been discussing, hey, maybe for on-prem Kubernetes clusters, MPI is a preferable way of how people do training today. Yeah, I'm just speaking about training perspective, right? For like model training,
Sure.
right? And especially for specific device placements and how you communicate between the devices to do distributed compute, right? I think what would be really helpful to understand the differences, especially on the performance level. Like if you've done any benchmarks or any like comparison between like using just Kubernetes and using Slurm for training, and just to see what is the recommended way we should give to our users, right? If they want to have a scalable platform for training, right? Yeah, I hope that.
I'm sure there are Slurm specific benchmarks. We are working within the Kubernetes ecosystem, so we don't have the full granularity that you would get otherwise. Skylar, do you know where those benchmarks are? Because I will tell you that most people are using Slurm behind the scenes for training. They're not using Kubernetes because of a performance issue. Yeah. And scalability. Scalability is a big one.
I think do you see the scalability performance when you use Slurm with Kubernetes? Are you going to see any limits with scalability compared to using just bare metal, right? And deploying.
So, sure. So when you go and you look at our roadmap, we are working on a Slurm bridge, which will enable that scheduling, which is basically to pull it out of Kubernetes and allow us to use the Slurm proper to do the scheduling. And that will be for either Kubernetes or for Slurm jobs. You won't, the first round turn of the crank, you won't be able to commingle them. So you can have Slurm and Kubernetes running on a node and have Slurm doing the scheduling. But some of the reasoning behind that is that Kubernetes is a very string heavy operation for the scheduler layer. And when you look at Slurm, it does a lot of clever tricks and algorithms that have been developed over years in this area that allow faster scheduling. And you'll never get 100% optimal because it's an NP complete problem, but you will get good enough to run at a performant way. Does that help?
Yeah, absolutely. I think that makes sense. I know that some people, for example, use Unicorn to replace the default Kubernetes scheduler to achieve some of the specific scheduling techniques for Spark, for example, right?
Yep.
So yeah, I think here you kind of can have the same capability. Do we have any other? Yeah, go ahead.
I'm at the point when we are solid enough in our code to do these. It would be nice to work with some or have some Kubeflow people who actually want to go and get this running over there, because that would be interesting.
Yeah, I think that would be interesting to, like build, for example, like runtime for Slurm. I know, like you are like we're kind of working right now to see how we can transition our training comparator to something new, especially with capabilities to, give users ability to choose MPI or torch run, or maybe they just want to use, native framework, capabilities. And I think building the runtime for Slurm, leveraging this Slurm operator will be really interesting for us to, especially to compare those things, right? And to give users exactly what they need in a specific use case, right? Because I guess I see the value of, building this runtime. And then, and at least on a training side, right? So we're not speaking about serving or other parts of, ML story, data preparation, right? For example. But for training, yes, we can definitely make something here. What do you think about it? How does it sound to you?
So one
Yeah,
of the piece, go ahead, sorry.
no worries. So yeah, so good point. So actually the train job bit is extensible for any frameworks, as you can see in the enhancement proposal. So maybe if it's possible, so we can add some parameters under the training runtime, custom resource, ML spec fields for SRAM nodes parameter. So does this you are imagining, Andre?
Yeah, I need to take a look. I understand because Slurm operator has two customer sources today, right? So I have the concept of like the cluster and also the node. What is the name of the customer source, right? The second that you showed, right?
Node set.
This,
Node set.
Yeah, node set, right? So we just need to see, whether we can leverage the job sets to, start maybe, Slurm as a batch job, for example, right? Because imagine you can start a Slurm cluster, run the job, and then shut it down, right? When the job has been complete. So this also could be an option, right? In addition, we can see how we can leverage those CRDs within the job set to actually, start a training. Because usually, the training is like the batch process. You don't want to have like a long running cluster, right? If you just want to, train your model, right? So we just need to see how we can leverage those CRDs within the training runtime.
I see. In that case, maybe so we need to implement another training runtime custom resource separate from current job set base training runtime resource. Actually, so as my understanding, so we are planning to implement single node training runtime and multiple node training runtime resource. But so in the first iteration, so we decided to implement only simple training runtime class. So so maybe so throughout some investigation, so maybe so we want to add another training runtime resource for SRAM node resources.
Yeah, I think we can definitely think about it. So I think I can start an issue to see how we can leverage this Slink operator, or like we can collaborate with all of you to see. So from your perspective, what exactly right now you're looking for? I know you're kind of improving Kubernetes, so, like with this these things that we're talking about, right? From the Kubeflow side of things, what kind of integrations you are looking for from us?
yeah, so I think it may be more useful for us to wait until we finish the Slurm bridge piece and do that as far as the scheduling is concerned, so we don't have to change the infrastructure for Kubeflow proper. As far as the Slurm operator piece, I think we need to figure out how to do the interconnect either through the MPI operator or something else between the Slurm nodes. Because the networking is still your normal CNI based networking. So we're still going to have to go through that interface or find another optimization that works better.
Yeah, because so interconnect between the nodes right now, you don't have any options, or how do you do interconnect? Like for
So this is a first round. So this is the current whatever is available in Kubernetes.
okay.
So if you want something particularly clever, I'm sure there's someone who's done something smart with Multis. But as we get smarter, right, we still don't have, for instance, this piece with the network topology with bandwidth and latency. So we need a way to expose that, possibly also through DRA.
Yeah, that makes sense.
Yeah, this is just the first round.
Okay. Yeah, absolutely. That makes sense.
Yeah.
We have 10 minutes. I also want to give like some time for Shao to give us the presentation. So any last questions? I know we can follow up on the next calls, but any other questions from the community?
So can I ask so last two questions? So the first is this SRAM 2 is open source project or not?
It will be. We're planning to release by KubeCon at least the operator, and then we will add on top of that as we finish other components. So it will be open source.
I see. So KubeCon means the next
November.
KubeCon next. Yeah, I
Yeah.
see. And so the second question is, so is there any way to access to existing SRAM cluster separate from Kubernetes using these SRAM tools?
Not this particular one. There will be when we do this, sorry, too many slides. When we do this Slurm bridge, you'll be able to still access the underlying Slurm cluster directly through the Slurm REST API. I mean, your other option is if you want to go play with Slurm proper, you can just build it bare metal, just like you do Kubernetes on your nodes from the, I believe the nodes have the Slurm documentation, which is also open source, and just run it.
Sounds good. Thank you.
Right. I think, Marlo, if you can share these slides would be also very helpful for us.
Yep.
And just also keep us posted on the, I guess on the KubeCon, after KubeCon, we can again see how we can, you know, if when it be open source, we can maybe by the time think about some integrations that we can do to try this out, at least for on the training side of things perspective, right?
Yep. That would be great. Thank you.
Thank you so much for presentation. Thank you, Tim.
No problem.
All right. Do you want to share your screen? I know we have like 10 more minutes, but maybe, you know, I can record this call, and if anyone else we need to drop, we can, you know, see the recording. But do you want to present your demo right now?
Yeah, I'm okay. I also prepare a slide for it.
All right.
But the time is not enough. I wonder whether I need to display my slides. What do you think?
Yeah. So how much time do you think you need for the demo and for the slides?
10 minutes or so.
10 minutes? I think 10 minutes is fine. So maybe, you know, we can do it right now.
Okay, thank you. Let me share my screen, and then let me share my screen. Hi, I'm Shao. I'm a student working in the JSON project, JSON named Google Sum of Code. I work on the push-based metric collection, this project, and I will briefly introduce my contribution during the GSOC. I have raised 11 PRs in this period and 2 PRs before the GSOC, and I have also raised 9 issues and 2 code reviews for others. My PRs mainly about my project, but I also have some other PRs for fixing some dependency issue and some cascade issues, and also some UI issues. And also, I want to introduce the background of matrix collection in the KTIP. Currently, the matrix collection is pro-based and sidecar container based. Please allow me to introduce what is the matrix collection. What is the sidecar container? In Kubernetes, the official website, sidecar container means that sidecar containers are the secondary containers that run along with the main application container within the same pod. These containers are used to enhance or extend the functionality of the primary app container by providing additional services or functionality such as logging, monitoring, security, or data synchronization without directly altering the primary application code. So in my case, the matrix character is the sidecar container, and it is injected by the mutated webhook. Mutated webhook injects the sidecar container to the training port, and the matrix character will collect the matrix in the training container and push the matrix into the persistent API of the KTIP. And the child controller will get observation logs from the DB and update the metrics to the child, which is created by the experiment. Yeah. So this is the current metrics collection. But it has some drawbacks. I conclude 3 drawbacks of the pool-based metrics collection. First is the design problem. Since we implement the sidecar container for collecting metrics, so we need to define the frequency to script the metrics so that we can get the metrics. But the question is in which frequency we need to script the metrics, and it's hard to determine this, and it also raises some performance issue because sidecar container may consume some resource. So there are some resource overhead caused by the sidecar containers. If we can discuss the sidecar containers, we can reduce the resource overhead of it. And it also has restrictions for environment. That the environment must support sidecar containers ingestion and the admission webhook, but some vendors does not allow admission webhook. So I introduced the push-based metric collection. In that case, we no longer use the sidecar container. Instead, we in the training pod, we directly code the report metrics in the training code, so we can push the metrics directly to the persistent API. Yeah, in the former case, we need to use the metrics collector to collect metrics and push them to it. In that case, we no longer use in the push-based metric collection. We no longer use the sidecar container, and we use report metrics instead. Please let me introduce a report metrics. This is a new interface that I defined in the Python SDK. It will push metrics directly to the CatibDB. Yeah. So it will do good to the DevOps engineer. And I offer a user story for the DevOps engineer. It can avoid the design problem I mentioned before. We no longer need to define the frequency to script the metrics. And also we can avoid some performance issue, and we can reduce the resource overhead caused by the sidecar containers. And also, so we can avoid environment restrictions. So it can fit in more environment. And I also have a user story for data scientists. In the before, we need to define to print certain formats of the metrics for metrics to collect. But now we no longer need to obey a format. We just need to define parameters of dictionary type, and we can just use this neat interface to push the metrics to the CatibDB. And data scientists no longer need to worry about the format of metrics printed in the training scripts, and there are no error anymore. Next, I want to show my demo for the push-based metric collector. First, let me introduce it. As you know, the core part is this. We will report metrics directly to the CatibDB, and we no longer need the sidecar container. And this is an objective function for the training, and we use tune function to define this. And what's more is we need to install the Kubeflow package in the training container, or we can't. Otherwise, we can't use this report metrics interface. And currently, it's not released in the current version, and I think it will be released in the 0.18.0 version. So currently, we need to use this method to download the newest version of the SDK. So let me first delete the experiment I created before. Now and we run this script, and we can see that there are a new port created recently. It's a suggestion container. We create the container offers an algorithm to the hypermeters, and these three ports are the child port. In a child port, or in each child port, we execute this objective, and the parameters are given by this suggestion container, and we just need to wait it to end, and it will report the metrics to the activity. I think it's maybe some error. Maybe have some error. I think it's a it may exist some error. Okay.
Or maybe did you check the latest changes from the upstream?
Oh, maybe they are updated in today or yesterday. The last time I checked it was correct. Okay, it's mean that it's broken.
Yeah, we need to probably see the master changes in SDK.
Yeah. Sorry for that.
No worries.
I
By the
need
way,
to
like
check.
if you want, you can use a specific commit in your packages to install, right? Not like from the master branch.
Yeah.
Like you can basically use the commit from your latest changes, right?
Yeah.
Yeah, maybe you can take this one, right? Fix drill RPC RPI.
And I need to copy it here.
Yeah, it should be right here if I remember correctly.
Yeah. I just need to wait for this to terminate. Sorry for that.
No worries. Can you check the packages to install? Do you have like the full path to the location? Yeah, that's great. Let's try this.
Okay, we need to apply it. And we just need to wait for it. Yeah, it
Yep.
will push the metrics. It seems good.
Maybe we can check the logs from the trial, or you don't have any logs there to see that the trials will be succeeded.
Yeah. I have a
Oh, okay, you have UI.
I have a UI. You can see the trials is running, and the situation volume assigns the value to the trial. And we can just watch this. Oh, some trial completed. Yeah. And three trial are completed, and we got the best value is 67. And we need there are another trial to wait to be completed. I think it will be completed soon. maybe downloading this patch needs to consume a lot of time. Okay, it also completed. Now the suggestion container is terminating, and we got the best value from the experiment. Yeah. And we can just, oh, that's fine. And my stats are over. Thank you to the folks and Angie, the Yuki. Thank you. Thank you for mentoring.
Thank you so much, Shao. This is a great demo. Thank you for the presentation. Any questions? I know over time, but any questions from the community that you want to ask? Yeah, I think it was really great. I think only my question that I might have. So how do we make sure that user will actually do we have any kind of visibility for users that they going to report the metrics? Like, for example, what if what happening if they just forget to do so? How are we going to inform them that they need to do the specific check in their training code?
Oh, if the metrics are failed to report here to the fail to report matches to the DB, and the users will receive a result that the matches are available, so that they will check the matches.
I see. So basically, we have a specific status, right, to report to the user.
Yeah, we will get the optimum hypermeters, and if it failed, they will report unavailable metrics, and users will need to figure out the reason, mainly due to the wrong format. Because for example, the option metric name defined here is result, but they can have misspelling or other things.
Yeah, that makes sense.
Yeah.
I think also my
Yeah,
question is, so do we report the timestamp? So if you go to the UI, can you see the timestamp for the metrics correctly reported? So if you check on the UI and the KTP UI, if you open the one of the trials, right?
Yeah.
So it's my question is like inside the trials, if you open one of them, can you see the timestamp for the?
we can see the timestamp.
Okay, that's great. That's great. So basically, we can see like the how metrics been populated during the period of time, right? That makes sense.
Yeah.
I have one question.
Yeah, go ahead, Dipankar.
Yeah, so like, can we configure like what metrics to be shown, or does it show all metrics by default?
Your question is the
like, can we
the
select
metrics
metrics
show?
to record?
We can show multiple results. For example, if you define another matrix name, define an additional matrix name here, and you can report the matrix here also, and it will be shown in the UI, and you can get the matrix 2 in this function.
So there is a set of defaults, and you are saying that we can add additional metrics.
Yeah, you can fill in your metrics you want to report to the tip in the additional matrix names. and report it directly in this function. For example, add another matrix, for example 3, and you can see the matrix in the KDB UI.
Okay.
Thank you for your question.
Yeah, I think it would be interesting to see how we can validate that which metrics can be passed from this function. But I think it's kind of like follow-up. I think we can discuss. For
Yeah.
example, like I cannot pass any random key value pair here, right? But
Yeah.
anyway,
So
go ahead, Yuki.
yeah, can I ask some questions? So thank you for great contribution during this project. So by the way, so when users my question is, when users accidentally push same metrics to CartDB, what happens?
You mean the user push the wrong name of the matrix to the KDB or other things?
I meant, so users push the same matrix value and key into CartDB, the situation.
Oh, I
So
haven't
is there any
investigated.
validation?
I haven't investigated this.
Mhm.
Import the
Yeah.
same value to do me the result.
Yeah, so I can imagine, so we execute cut report metrics command double time with
Oh.
same key value.
Oh, I haven't investigated this. Maybe I should add some conditional checking in the report metrics. Thank you for reading this.
Yeah, let's start an issue for this. I know we're like very over time right now on this call, so I think thank you for asking, Yuki. Let's definitely start an issue.
Yes.
For
Thank
this.
you for a great. Yeah, thank you for a great
Yeah.
great question, and Yuki.
All right.
Yeah, great. Thank you.
Okay, yeah, I think in any case, again, thanks for the presentation, Shao. I think we will again give a presentation next week on the community call, so other folks can also, take a look and ask their questions.
Yeah.
Thank you for all of your contributions. We're looking forward, to continue work with this and to improving this feature and all the features we are working on. So looking forward to all of these future contributions from all of you. All right.
Yeah.
Thank
you.
Right. Thanks so much for your time today. Let's definitely sync in a couple of weeks. Thank for great presentation for Slurm and also for you, Shao. So yeah, see you soon, everyone. And I will start the issue to discuss all these things that we talked today. Thanks, everyone. See you soon.
Thank you.
See you.
Thank you.
Thank you all.